Welcome to another deep dive. Today, we're going to be tackling some pretty uh, cosmic questions.
Yeah.
We've got this fascinating article, and it's summarizing a discussion between astrophysicists Neil deGrasse Tyson and Charles Liu,
Okay.
along with comedian Paul Mecurio.
Interesting.
So it's like this brain trust, of the universe.
Yeah.
They take on reader questions covering everything from gas clouds to the Big Bang itself. So are you ready to sort of explore the universe's biggest mysteries?
Absolutely. And I think what's so intriguing about this source is that it really does tackle such a wide range of topics, like a
Yeah.
deep dive should.
Yeah. And the first question that really caught my eye is one that I've kind of always wondered about.
Hmm.
How do these enormous clouds of gas, like nebulae,
Yeah.
even exist in space? You would think in a vacuum they would just dissipate.
Yeah, it's a great question. You'd expect the gas to just spread out, but there's a force at play
Right.
that keeps these clouds together. Gravity. And it might be weaker in the vastness of space compared to here on Earth.
Right.
But it's still strong enough to bind these gas clouds over incredibly long distances.
So even though space is mind-bogglingly cold, around negative 400 degrees Fahrenheit, gravity is sort of like the glue holding these nebulae together.
Exactly. And it's not just holding them together statically, it's a dynamic process.
Okay.
We have to think about the concept of hydrostatic equilibrium.
Hmm.
Gravity pulls the gas inward,
Right.
but the gas itself has a certain pressure that pushes outward.
Okay.
These forces reach a balance,
Gotcha.
preventing the nebula from collapsing completely and allowing it to maintain its structure.
That makes sense. So it's like this constant push and pull, between gravity and gas pressure.
Right.
It's incredible how these forces, shape these stunning structures that we see in these images,
Exactly.
like the Orion Nebula.
And that's just one type of nebula.
Oh, right.
There are several others.
Yeah.
Emission nebulae, for example, glow with vibrant colors because the gas within them is energized by radiation from nearby stars.
Oh, wow.
Then there are reflection nebulae,
Okay.
which don't emit their own light, but rather reflect the light from nearby stars.
Oh,
They often appear bluish because of the way they scatter starlight.
wow. So there's so much diversity, even within something as seemingly simple as a gas cloud.
Absolutely.
Makes you realize just how much complexity there is out there in the universe.
Yeah, and these nebulae play a crucial role in the universe's grand story.
Oh,
They are the birthplaces of stars.
that's right. We were just talking about gravity and how it keeps these clouds together. I'm guessing it also plays a role in star formation.
Absolutely. Within these nebulae, certain areas are denser than others.
Okay.
Think of it like pockets of higher concentration within the cloud. These dense pockets have a stronger gravitational pull,
Right.
and over time they start attracting more and more gas and dust.
So gravity's acting like a cosmic vacuum cleaner, pulling in all this material.
Yeah.
What happens next? Does it just keep growing forever?
No, there's a limit.
Okay.
As more material gets pulled in, the core of this dense pocket gets incredibly hot and compressed.
Oh, wow.
Eventually, the temperature and pressure reach a critical point and nuclear fusion ignites.
Hmm.
That's when a star is born.
Wow. It's amazing to think about all that chaotic gas and dust, coalescing into something as magnificent as a star.
It is.
It is. But here's something I find even more fascinating.
Okay.
Not all the gas in a nebula gets used up in star formation.
Right.
Some of it remains as what we call the interstellar medium.
Yeah.
So it's like leftover ingredients after baking a cosmic cake. What happens to this leftover gas? Does it just float around aimlessly?
Not always. Some of it does just kind of hang out there, But a galactic rotation and things like temperature can influence its fate,
Right.
if conditions are right.
Uh-huh.
Gravity might gather enough of this leftover gas
Okay.
to trigger the formation of new stars.
So it's like the universe is constantly recycling,
Yeah,
with the remnants of past star formation playing a role in the birth of new ones.
exactly.
Pretty remarkable.
Yeah.
So we've got these giant gas clouds,
Uh-huh.
gravity pulling everything together,
Right.
stars forming and dying.
Yeah.
Makes you think about the bigger picture, like, how did the universe even begin?
Speaking of the bigger picture,
Yeah.
our source material actually tackles that very question
Really?
with a listener question about the Big Bang.
Oh.
They ask what exactly went bang.
That's a question I think we've all pondered at some point.
Yeah.
What was it, some massive cosmic explosion?
It's a common misconception.
Okay.
But the term Big Bang is actually a bit misleading.
Hmm.
It wasn't an explosion in the traditional sense, like a bomb going off.
Oh.
It was the rapid expansion of space itself.
Okay.
From an incredibly hot, dense state.
So it wasn't an explosion in space,
Right.
but rather the expansion of space itself. That's a pretty big distinction.
It is.
Yeah.
Imagine a tiny, incredibly dense point
Huh?
suddenly stretching out in all directions.
Oh, wow.
More like a balloon inflating than a firecracker exploding. And the fascinating part is this expansion is still happening today.
So the universe is constantly stretching, getting bigger and bigger.
It is.
It's hard to wrap my head around the sheer scale of it all.
Mind-boggling, isn't it?
It really is. And to make things even more interesting,
Yeah.
the term Big Bang was coined by an astronomer who actually disagreed with the theory.
Oh, wow.
So it's kind of a cosmic irony.
It is a bit ironic.
Yeah, so if it wasn't an explosion, what caused this rapid expansion of space?
That's a question scientists are still working to fully understand.
Okay.
But a key concept is cosmic inflation. This refers to a period of even faster expansion.
Hold on, faster than the already mind-boggling expansion of the universe.
Yes.
Wow, I can't even imagine.
It's difficult to comprehend, but that's the current understanding. And this incredibly rapid expansion actually helps explain some of the observations we make about the universe today.
Like what?
For example, the cosmic microwave background radiation. A faint afterglow of the Big Bang is remarkably uniform across the sky. This uniformity is difficult to explain without cosmic inflation, which would have smoothed out any initial irregularities.
So this period of superfast expansion right after the Big Bang helped create the universe as we know it, smoothing things out, setting the stage for everything that followed.
Yeah.
It's like hitting the cosmic gas pedal right from the start.
That's a great way to put it, and it's fascinating to think about
It is.
how this initial event, billions of years ago,
Right.
continues to shape the universe we observe today.
Yeah, it really is incredible to think about all of this, gas clouds and star formation and Big Bang.
It is.
All interconnected like this. It really paints a picture of a universe that's just constantly, evolving and changing.
It does. And speaking of the universe's evolution, there's another question that often comes up. If the universe is constantly expanding,
Right.
does that mean there's an edge?
That's a question that's always boggled my mind,
Yeah.
It's like trying to picture the end of infinity,
Right.
Is there a boundary out there somewhere?
It's a question that has puzzled cosmologists for a long time, and the answer isn't exactly straightforward.
Okay.
One possibility is that the universe is infinite, extending forever in all directions. In that case, there wouldn't be an edge in the traditional sense.
So no cosmic fence at the end of the universe.
Not quite.
Right.
But if the universe is finite, things get even more interesting.
Okay, how so?
Imagine the surface of a balloon.
Okay.
It's finite,
Right.
but it doesn't have an edge. You could travel around it forever without ever reaching a boundary.
So you're saying the universe might be curved in on itself like a giant cosmic sphere?
Exactly.
That's a wild concept to wrap my head around.
It is, and it raises all sorts of fascinating questions about the nature of space and time.
Right.
It's a reminder that the universe is full of mysteries, and the more we learn, the more we realize we don't know.
This whole deep dive has been a journey through some of the most mind-boggling concepts in astronomy.
It has.
How gas clouds come together to form stars.
Right.
How the Big Bang wasn't an explosion, but the expansion of space itself.
Yeah.
We even contemplated the possibility of an infinite or curved universe.
It's incredible.
It really is.
And I think that's the beauty of exploring these topics. It challenges our assumptions.
Absolutely.
It forces us to think beyond our everyday experiences,
Sure.
It's a reminder of the vastness and wonder of the cosmos.
Absolutely. So as we wrap up this deep dive,
Yeah.
what's one thing our listeners should take away from all of this?
I think the biggest takeaway is to never stop being curious.
Yeah.
The universe is full of unanswered questions, and it's that curiosity that drives us to explore and learn more.
Right.
Whether it's pondering the nature of gas clouds or contemplating the origin of the universe,
Yeah.
keep asking those big questions and seeking out answers.
Well said. And on that note,
Mm-hmm.
we've reached the end of our cosmic journey. So thanks for joining us for this deep dive into the mysteries of the universe. And until next time,
Right.
keep looking up at the stars and wondering about all that's out there